All right. All right. So I think it's on this time with the audio. There we go. Okay. Ready. All right. So we got a few things to talk about today. The first one is, so let me just kind of go to the announcements. I'm hoping everybody can get to the announcements, like get it by email, because otherwise you can be missing something and you don't even know it. What we'll be doing today is to go through exam one from the previous semester. So I'm going to walk through that particular exam. And I also prepared the exam policy and the preparation guide. So I hope some of you, had a chance to take a look at both of these. The exam policy is not optional. You have to read the exam policy, before the exam, or I'm going to make the assumption that everybody would have read the exam policy before the exam. And we can talk about that, maybe on Wednesday. It's not too big of a concern, in terms of what we need to go over today. And then the other one is the exam preparation guide, which has, what I think, can be helpful to help people prepare for exams. So it starts with my explanation of, what I usually look for in my exams, followed by, a discussion on study guide, because I was asked about the study guide in the previous class. And as I explained to my earlier class today, until I became a professor, I was never even aware of the thing called a study guide. That phrase never popped up in my mind at all when I was going through college. So, for whatever strange reason, that was just not a thing that I needed to do. So anyway, I did find two links to help people create their own study guide. So this is one, and this is the other one. So you're encouraged to take a look at how to make your own study guide. And then the last one is a reverse timeline. Basically, 1 week before the exam. What I think people can do to help prepare for the exam. 2 days before, 1 day before, the night before, and then on the day of the exam. So this is all linked, from the document, from announcements. So you just have to go to the announcements to get access to this document. All right. With that said, okay, if anyone has any questions or comments about those documents, we can talk about that on Wednesday. What I want to do today, is to go back to exam one from spring 2022, which is the previous semester, and we're just going to work through these questions one by one. You have access to this document too. I think I made it so that you guys. Oh, okay, there we go. We see a bunch of people sharing the document or viewing the document at the same time, so that is good. And what I will do is to let me go full screen here. And what I can do is I can give you the answers of all of these questions. I'm just kind of debating with myself, how to give you the right answer. I think I would just use a small text editor on the side to write down the answers. So let me drag this over here, and we'll try to make sure it doesn't block too much of a question. So for now, it's going to be this wide. All right, so we can now go ahead and take a look at exam one from last semester. Most of the instruction here will still apply to you, about the exam being individual, but we don't have Discord, in this class. It's all face-to-face. So exam one, exam two, and also the final exam, they will all be in person, and also, all of those will be on paper only. So that means if you have been taking notes using the tablet or something like that, you will have to print out, the content, to prepare for the exam. Now, what can you bring to the exam? It's open book and open notes. So you can basically bring your own notes. You can print out the modules that I have written, bring those with you, as paper copies. You can highlight, you can use stickies and whatnot. There's no limitation as long as what you bring in is either handwritten or printed prior to the exam. Are we good so far? Or if you like one of the screenshots, in the video, just take a screenshot, print it out and bring it with you. So all of that is fine. There's no limitation of what you can bring as long as it is printed or handwritten prior to the test. All right, moving on. All right, so here's question number 1. And let me see if I can turn off all the complaining about. It's all, this is language tool, it's complaining because, let me see if I can turn it off. Turn off rule everywhere. Nope, that's not what I want. Nope. Is that bothering you, all the red lines and whatnot? Nope. Okay. All right, so we're going to look at question number 1. Okay, you are given that f equals 2, and in this case, let's see what f is, okay? This is the content of f. And what exactly is it? First of all, it is a set, right? And then what is each element in the set? Yep.
Each element of the set is a set and then another element.
Well, each element is not a set. It is
a set containing a set.
It's a tuple. It's a tuple because of the parentheses. So we have the parentheses first, and then we have the braces again. So each element inside the set is a tuple, where the first element is a set, and then the second element is just a number. Okay, so I want to make that clear first, okay? Because I want to make it clear that make sure that everybody can read the notation and understand that we have a set of 2 tuples, where for each 2 tuple, the first item is also a set. Are we good so far? All right. Now the question is to say this one says create set X such that blah 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 blah. Likewise, create set Y such that blah 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 blah. And we also want f is a function mapping from X as a domain to Y, which is a codomain, if and only if P of 1 f x y. So the first thing we need to do is to find out what is P of f x y. And that predicate is defined in the earlier part of the question. This is P1. This is P1, which is a predicate. So this is the first thing we want to look at and try to figure out, okay, what exactly is he saying? Okay, so we'll read this step by step, okay, and see if we understand what is P1, which is basically a predicate. A predicate, once again, is a function that returns a Boolean value, something that's either true or false. Turns out that we have 3 parameters in this case. We have f, we have d, we have e. And now we have to find out, okay, what exactly is it returning that depends on f, d, and e. Are we good so far? Okay. So now, the first thing is f is a subset of d Cartesian product with e. Okay, so that's one thing, right? Yeah, we know that f is a subset of the Cartesian product of d and e. So now, right away, I know that d is a set, e is a set, and so is f. They are all sets. Okay, and this is the conjunction symbol. So during the exam, I cannot tell people what a symbol means. So this is part of your job to go through all the notations, all the symbols, and remember what they stand for. Not remember, because remember you can bring in any number of sheets of paper. So my recommendation is to make your condensed version of all the notes, so that you can find all the information quickly. And I guess that is a study guide, so to speak, is a condensed version of everything that we have learned up to this point in a way that you can find the information quickly. All right? So what is on the other side? We have a universal quantifier for all, W in D. So that means if I pick anything in D, which I call W here, the following should be true. Okay? So now we have the cardinality. The bar is the cardinality. And you can only take the cardinality of a set or a tuple. In this case, we have a set. So this is WY, where W is whatever thing that's coming from D. Y is unbound, which means Y can be anything, as long as WY together is an element of F. And we want this particular set to have exactly one element. Does that sound familiar to you? Because it should. We have seen this notation already. It's just that I did not use the same letters, the same variable, the same same parameters when we encountered this the first time. So what was it? What is exactly P1 trying to say? Oh, go ahead.
I was gonna say injection.
No, nope. Go ahead. Nope. Yep.
It's a function.
It is a function. Very good. Good job. So all P1 is trying to say is F is a function using D as a domain and E as a codomain. That is all that it's saying. So this is the first thing is to try to understand the question and also understand the notations of the exam. Is that okay? Now you look at your P2 and P3, they should also look familiar. The only difference is instead of W being an element of D, this is a W is an element of E, and instead of W being the first thing in the two tuple, W is the second thing in the two tuple. So P2, okay, I know it may not be relevant for this test, but P2 is asking whether every element in the codomain is mapped to up to once, which is testing whether F is a injection or not. And then the last one, which is P3, is asking, do we have at least one thing mapping to each element in the codomain? And that's asking whether F is surjective or not. All right? So right off the bat, okay, this is stuff that we have seen in the module in the notes already. And we kind of have to remember how to read something like this. Now you can see that P2 refers to P1 because it makes no sense to talk about injection or surjection when we don't have a function to begin with. So F has to be a function first, which is what P1 is trying to confirm, and then we can confirm whether it is an injection or and also whether it's a surjection. So if P2 is returning true, it is an injection. If P3 is returning true, then F is a surjection. It can be both, because this cardinality can be exactly 1 for every element in the codomain, in which case F is a bijection. In a weird way, in a very, very weird way, this is kind of a study guide. I'm giving you the definitions already, except I'm not telling you what it is. But it is, the definition that we have already talked about in this class. And I even, make it clear, F is bijective if and only if PB is P2 and P3. So, that's just what I said a little bit earlier. All right, so getting back to question number 1. So question number 1 is asking, create set X such that for all X, there exists a Y such that XY is an element of F if and only if X is an element of X. Lowercase x is an element of uppercase X. Okay, what is that asking? So it's asking for every X in the entire universe, for everything, that there exists a Y somewhere within the universe, such that XY is an element of F if and only if X is an element of X. So what is it trying to ask? How do you construct X, uppercase X in this case? Yes?
Since the set F is a two-tuple,
it's a set of two tuples.
Yep. It's a set of two tuples. Each element of F has two elements within it. So
two things in it.
Things in it. So each element of X is one of those things.
It has to be, okay, because remember, each thing in F is a two tuple. So which one do we want? Do we want the first thing or the second thing?
Either of the ones for the first thing.
Not either. So look at the notation carefully. X is specifically the first thing.
Okay.
So we only want the first thing within each two tuple that is an element of F. We collect all of those things, stash it into its own set, and that would be the set X. Is that okay? All right, so I'm going to give you the answer, but if you're not quite understanding why the answer is the answer, then we need to talk about that too. Okay, so I'm going to say Q1, and X is in this case. So the first one is 2, 5, 6. The second item is 4, 5, 3, 2, 6, 1. I mean, this was designed to be in the electronic test, so copy and paste would be possible. So doing this on paper obviously is not going to be as quickly, as efficient. So I will adjust for that too. So that would be the answer of what X is, because X is basically collecting the first item of every single tuple in F. Do we have any questions about the notation? This thing here that says there exists a Y simply means Y can be anything. I don't care about Y. Because we still have this constraint that X, Y together as a two tuple has to exist in F. If we want X, lowercase x to be in uppercase X. Is that okay? All right. All right, so what about Y? What is the difference between the construction of X versus the construction of Y? So in this case, you can see it's almost the same thing. For all lowercase y, there exists an X such that xy as a two tuple is an element of F if and only if Y is an element of Y. Lowercase y is an element of uppercase Y. So what we're really doing is we're collecting all the second item of each two tuple from F and put all of those into a set Y, uppercase Y, and that would be the answer. So now we have Y having 50, 63, 4, let's see, 13, and 1. There we go. Are we okay so far? Okay, you don't. Okay, I'm assuming there are no questions. If we don't, ask me. So P1 of fxy is now asking, is F a function using X as a domain and using Y as a codomain? That one is pretty clear. So what do you think?
Yes.
Yep, it is, because of the very definition of how X and Y were created. X is the first item of everything in F. Y is the second item of everything in F. So by that very definition, we have already kind of made sure that F is indeed a function. So P1 of fxy is true. So that would be the answer. Are we good so far? All right. Now, the next one is if F is not a function, explain why F is not a function with X as domain and Y as codomain. Okay, it doesn't apply because we have already confirmed that F is indeed a function. So now we can skip to this part here. So this part is it's a little tricky to read, but I'm gonna go a little bit slower to explain what it's asking. This part should be answered only if F is a function. Okay, we have just confirmed that F is a function. So now the question is asking, note that there may be multiple solutions. You only need to find and present one solution. So there are several ways to define A, B, and C, and they all meet all the constraints as described here. Find sets A, E, and H such that A, f of A is an element of F, E, f of E is an element of F, and H, f is an H, f of H is an element of F. Find some sets B and C. A does not equal to B, and A does not equal to C, and B does not equal to C, which means they're all different. They are unique from each other. A, B, and C are not subsets of each other, and E equals to A union B, and HE equals to A union B union C. Okay, that's a mouthful. So what we want, what the question is asking is to find A, B, and C to meet all of those requirements. So that means the constraint would be E has to be the union